permutation is an arrangement of separate objects in a defined order. In other words, how many arrangements can be made of n amount of objects when only r amount are chosen from them? The formula for permutations in a set is as follows, where the permutations over here is equal to the total number of objects in the set, factorial, divided by the number of objects subtracted by the number of objects actually picked to arrange, and that is also to the factorial. So we got n factorial over n minus r factorial. So the strategy that we commonly adopt when we're solving or approaching a permutation problem is to determine the total number of objects n and how many are being picked, and that would be the r variable in the equation. Then we would substitute both of these into the permutation formula, and we're going to simplify the expression. Now, one thing I do want to mention is sometimes people find it hard to recognize when you're looking at a permutation. So some of the keywords you're looking for is any mention of order or arrangement, or words that infer order. So that's stuff like unique, okay, or to isolate. So anything that infers order, mentions order, or uses words like arrangement, you're dealing with a permutation problem. Now, sometimes when we're putting it into our calculator, we actually use the permutation notation, which is where we say n, which refers to the number of sets in the arrangement or number of objects we're picking from. So n choose, and then how many objects we're actually choosing from that set. So for example, if out of 8 events, I'm only choosing 4 of them to arrange, or I'm choosing to arrange those 8 events into groups of 4, then I would write it like this. And I wrote C, but it actually should be a permutation. So out of 8 events or objects, I'm choosing 4 to make permutations with. Mr. Elof Zimath has 10 different trophies. His shelf can hold only 7 of them. How many different ways can the trophies be arranged on the shelf? So, one of the things we talked about previously is how can you recognize if you're looking at a permutation question. And one of the key words that we look for is arranged, right? Because that's exactly what a permutation is. So, that word gives it away. The 10 different trophies over here, that is going to be the number of objects. So the 10 different trophies refers to the number of objects that we're going to be arranging. And the 7 is the objects out of the 10 that we're deciding to arrange. And so that would be the R, and then this would be the N. So if we're using our calculator, we're going to put 10 P7 or choose 7, and that would give us a permutation number of 604,800. Now, if we're using the formula, then it would look like this. So I'd write NPR is equal to, you go 10 factorial divided by, and then it would be 10 minus 7 close bracket factorial. You plug this into your calculator with the full factorials, and you're going to also get 604,800. And this is the number of ways that your shelf or your trophies can be arranged on the shelf. For our next problem, it reads, how many 4-letter arrangements can be made using the letters of the word factor, and then the second one, train yard. So again, the word arrangements tells us that this is a permutation. Now, what we're going to do is, as we stipulated before, the first thing we're going to do here is identify, well, how many factors are we choosing from? Or I should say, how many objects are we choosing from? In this case, every letter is an object. So we have 1, 2, 3, 4, 5, 6 objects. So there's 6 objects or events. And as the problem suggests here, we are choosing 4 of them. So this is going to be the R in the formula, and this would be the N. So if we're using the calculator, we would go 6, choose 4. And that would give us a value of 360 possible arrangements or permutations. And if we're using the formula, then your NPR is going to be equal to 6 factorial over 6 minus 4 close bracket factorial. Plugging that in carefully, and you will also get 360 possible arrangements. So either one can work. It really just depends on the capacity of your calculator. Now for the second example, or part B, same idea. We're trying to arrange this word into 4-letter arrangements, and how many of those can we do? So this time the amount of objects is 9. So the N is going to be 9 because there's 9 letters in the word train yard. And so if we're using our calculator, it'll be 9 choose 4. And this is going to give us 3,024 possible arrangements or permutations. And then if I'm using the formula, it's going to be 9 factorial over 9 minus 4 close brackets factorial. And as well, of course, you're going to get the same thing. And this is possible arrangements or ways that we can arrange this. 8 students are competing in a 200-meter race. How many ways can students finish first, second, and third? Okay, so because we're assigning something first place, second place, and third place, this is one of those instances where the order matters. So these terms infer order or suggest an order, because if you don't have some kind of order in your arrangements, then you definitely won't be able to assign anything that is first, second, or third. So we're either looking for order directly mentioned, the word arrangements mentioned, or the problem is stated in a way where you have no way out except to create an order in the way that it's arranged. In this case, that would fall into that category. And so we know that this is a permutation. So the 8 students that are part of the set, that would be the N. I wrote P here, but it actually should be N. I'm not sure what that was about. And then only 3 students out of the 8 can finish first, second, and third. So that's what we're choosing, 3 students to be arranged, or to arrange students, I should say, in 3 consecutive order. So this here, the 3 would be the R. And so if we're using a calculator, we would use 8 choose 3. And then that would give us a total of 336 ways that students can finish first, second, and third. Now, if we're using the formula, well, your NPR is going to be 8 factorial over 8 minus 3 close bracket factorial. And then this, again, plug it into your calculator, make sure to put the factorial signs, and make sure to use brackets, would still give us 336 ways. So solving algebraic expressions with factorial notations tends to be a little bit more complicated. So here's a recommended strategy. First, I would rewrite or expand as a product and simplify it down to 1. Or you can just simplify until you see that you've reached a common term in the numerator and the denominator. Now, when we're simplifying, remember that the goal is we're trying to eliminate a factorial from the denominator in order to make our isolating of the variables easier. Once you've got that, and you've removed like terms from the denominator, then you can isolate for n with algebra or factoring if necessary. So let's say we wanted to solve for n in the following permutation, where it's n choose 2 is equal to 56. So if I expand this, I would rewrite this first. So step 1 says rewrite and expand as a product. So we're going to go 56 is equal to, we have n factorial over n minus 2, close bracket, factorial, where we know that the 2 is the r, because the notation is NPR. Now what we're going to do is we're going to expand this as a product, and we're going to do that until we find something that could cancel out this denominator. Now we've expanded this according to the factorial form, where we remove 1 from the original every single time until we've gotten to something we can cancel out with, which is the n minus 2. Now, I put a factorial here because this thing could technically keep going on forever. And instead of writing n minus 2 all the way until it reaches a value of 1, I could just write n minus 2 factorial, right? Instead of writing 5 times 4 times 3 times 2 times 1, you can just write 5 factorial. So we finally stopped expanding here because we got what we need, and now I can actually remove the n minus 2 from the denominator, and that'll leave us with n times n minus 1. After expanding, we see that we've got a quadratic here, and that's going to present 2 solutions. Now, one way to get the 2 possible solutions is to factor the traditional grouping factoring, or you can do the quadratic formula. Both will give you the same answer. So once I got this over here, remember that this is really, again, this is n is equal to 8, and this would be n is equal to negative 7. So we know that you can't have a negative set of choices, but if you were to plug in this value over here, you would see that it does not equal 0. And so therefore it's an extraneous solution. And so the real solution is n is equal to 8. So we write, therefore, ed equals 8. Now the next example we're going to do is a little bit more complex. So let's say we're asked to solve for n in the following permutation expression. N factorial over 84 is equal to, and then n minus 2, choose n minus 4, or pn minus 4. So one thing I'm going to do immediately, I have it highlighted here, but this is going to refer to the number of sets, and this is going to be how many we're choosing from that set, or ordering from that set, I should say. So that'll be n minus 4r. And then on the left side here, it's n factorial over 84. Okay, what we're going to do first is we're going to expand this side over here. So referring to the regular permutation formula, we're going to substitute the n minus 2 wherever the n would go in the formula. So n minus 2 factorial over, and then it'll be n minus r, which in this case, it's n minus 2 minus n minus 4. This now breaks down to n factorial over 84 is equal to n minus 2 factorial over 2 factorial. And what we're going to do is we're going to try and group all the n variables together and all the non-n variables together, and then isolate. Simplifying this, of course, remember 2 factorial, it's 2 times 1. That's just going to be 2. So we're going to write n factorial over n minus 2 factorial is going to equal to 42. Now what I'm going to do is I'm going to expand this according to the formula of permutation. Now the way that this has been expanded is that, remember, when it comes to expanding factorials, you're taking 1 off the previous number each time. So I keep doing that until I get a like term, which over here, we have n minus 2 factorial and n minus 2. So once I get here, then I know that I can simplify, because the goal is we're trying to remove the factorial in the denominator. So once we simplify and I expand the brackets, I'm left with n squared minus n equals 42. This then turns into a quadratic, where we can say that's n squared minus n minus 42 equals 0. Then after factoring this quadratic, I get two possible solutions, n minus 7 and n plus 6. And remember that really is n is equal to 7 and n is equal to negative 6. Now it can't be both these answers, so what we do is we then plug each of these back into the original quadratic and see which solution is actually true. We realize that negative 6 is an extraneous error, an extraneous value, which means it doesn't actually give a true statement. So when we plug it in, it doesn't equal 0. When n is 7, though, it does. So therefore, the n value is 7.